Now this program is going to be about asteroids, and not everyone will know what they are. Well, asteroids are comparatively small worlds, going around the sun in the same way that we do, many, although not all, following the paths of Mars and Jupiter. And telescopically, they look like stars, but they're certainly not. They are quite different. Only one Ceres is as much as 500 miles across, and only one, Vesta, is ever visible with the naked eye. Well, to talk about those, first sent on back to America, one of my old friends, Alan Fitzsimmons. Alan, the Dawn probe has been sent up and is now orbiting at Vesta. Can you take us through the Dawn probe, tell what it is?
Well, it's a fantastic mission. It's a mission to visit both Vesta and Ceres, as you've mentioned already. It's in orbit now about Vesta successfully, and for the next year it's going to be studying in great detail this amazing world, which we believe has been there in roughly in the same place since the dawn of the solar system, and it's going to give us clues as to how the asteroids evolved over that time.
And we've got some amazing pictures of the kind we've never seen before. Just have a look on a few of them.
Well, I mean, these are fantastic images. We've had some very low-resolution shots taken by telescopes on Earth and, of course, by the Hubble Space Telescope. But these show the detail that really the Dawn mission was designed to provide.
Mountains, valleys and craters.
Absolutely. And many of the views, of course, at the moment, just of the southern hemisphere of Vesta, because as Dawn approached the asteroid, it came up really from below to get into orbit. And that was particularly important for us because what we're seeing in these first ever close-up images of Vesta is the sign of a tremendous impact that happened possibly 3.5 billion years ago that literally shook this small world to its very foundations.
I have to say, I have trouble picking out an impact crater on this image. Which of these craters is the impact crater that you're talking about?
The reason that in fact, I think we all have problems here, because here we're looking at a crater that's about the size of the body we're looking at.
The whole image is almost...
Absolutely. So when we look at this, we see this huge mountain facing us that's probably about 15 to 20 miles high and about 50 or even 100 miles across.
So that's, what, 3 times Everest if you scale up to Earth size?
Absolutely.
So relative to the size of the Earth.
Absolutely.
Wow.
About the size of the largest volcano on Mars, Olympus Mons. And that is, in fact, the central peak of the crater.
So this is material that was thrown up and came back down.
Absolutely. And then surrounding it, out to about the radius of the asteroid itself, is the depression or the bowl of the crater.
So on the right there, you can almost see those might be the walls that were once the walls of the crater, I guess.
Absolutely.
And scattered bits in all directions.
That's right. What we now know from telescopic studies in the 1990s and since then is that around Vesta in the asteroid belt are fragments of Vesta.
Some of these fragments of Vesta have actually arrived on the Earth, and I'm glad to say we have one with us now.
Absolutely, Patrick, and here it is. In meteoritical terms, this is called a eucrite, or a eucritic meteorite. And there's 2 things you can see when you look at this. First, we can see that it's composed of very angular, small, dark fragments. These are the fragments of original basalt that have been compressed into a rock by literally other rocks falling on top of them due to other impacts. Second thing, though, you notice is that you don't see any glittering due to metals.
No.
And quite often, as you know, when you find meteorites, they're highly magnetic because they contain lots of iron and
this
nickel.
one's not.
Absolutely not, and that's because Vesta was differentiated and formed its iron core when it was molten. All the metals, of course, sank down into the centre of the body by now. So this is relatively metal poor compared to an ordinary meteorite that we would find. So these 2 clues tell us that this came from a volcanic body.
So it's amazing to think that here in the studio we're actually seeing and touching a piece of another world so far away.
Absolutely, and of course some might say that if you know so much about it, if you've already got a piece here, why do you need to send a spacecraft to Vesta?
Ah, that's another story.
That's right. Well, in fact, of course, it's because we have this that we know it's worthwhile sending Dawn there in the first place.
So the mission's Dawn because, as you say, we're getting a trace of the early solar system. But can you give us a potted history of the solar system? We start off with the sun forming and a disk of material around it, and then what happens next?
Well, what happens next is somehow magically the solar system comes into being. And I use that phrase almost literally because we now have some fairly sophisticated models of what happens. Computer models, that's right. We can't unfortunately make our own solar systems just yet in real life. But these models imply that it was a very turbulent process in taking this disk of gas and dust and creating a planetary system out of it.
And so because it's turbulent, we have things flying all over the place. You've only got to look at the surface of the moon to see that, as Patrick knows. But what's happening to Vesta at this point?
Well, we believe that Vesta was one of a population of very large objects, several hundred miles across up to, that were formed at this time. But most of them have been lost in the subsequent history. They've suffered collisions, they've been broken up in those collisions, or they've simply been ejected from the solar system or destroyed by collision with the sun or another planet. And so when we visit Vesta, we really are looking at the last survivor from that epoch where the solar system was sorting itself out.
We know that the probe is now going round Vesta and sending back amazing pictures and vast quantities of data. Well, eventually, it's going to break free from there and go on to the larger asteroid Ceres, which is faint up as it's further outward, about 500 miles across. Now, Ceres and Vesta are very different, aren't they?
Ceres, although it would have been heated during formation as Vesta was, and it should be differentiated, it should have a core, mantle, even crust structure, as Vesta has, then because it was so far from the sun, its composition was much more dominated by lighter elements. So the rocks on Ceres are much more dominated by, for example, carbon and hydrogen and oxygen. And indeed, we believe that within the rocks of Ceres, there has been the action of liquid water in the past. And so if we want to think of Ceres as anything special, we would think of it as a water or at least ice-dominated asteroid.
Any ideas of landing on Ceres?
Well, that's a possibility. Of course, just as the near Shoemaker spacecraft landed on Eros.
Almost by accident.
Well, absolutely. I mean, it was not designed to land. That's right. Now, perhaps the best option is that there will be enough fuel left on board to fly Dawn to another third asteroid. There would not be enough fuel to go into orbit about it, but we could have another flyby of yet another unexplored world.
Well, Vesta was fascinating, and before long we're going to hear a great deal more about it. Chris, Alan, thank you very much. Well, quite apart from the big asteroids, there are many, many smaller ones, some of which come surprisingly close to the Earth, and one did so quite recently. And Paul Abel has been talking about these near-Earth objects.
We all lead busy, hectic lives, and the thought of an asteroid coming at us from the depths of space isn't something we worry about a great deal. We go to bed at night and presume our civilization will be there in the morning. But there are some big asteroids out there with the potential to do a lot of damage. Some of them pass dangerously close to the Earth. In the sleepy Berkshire village of Great Shefford lives an astronomical sentinel. By day, Peter Birtwistle works in IT, but by night, he is a defender of the Earth, scanning the skies for asteroids. Peter took this footage of asteroid 2011 MD back in June. It was the size of a double-decker bus and passed just 7,500 miles from the Earth. It looked so close you could touch it. Hello, Peter.
Hello.
Oh, this is a most impressive setup you have here. So, why don't you tell us then, how did you get involved with 2011 MD?
Well, I was out observing that night, following near-Earth objects that I'd normally do anyway, and the discovery was announced about 3/4 of an hour before dawn, which gave me just enough time to try and find it.
You must have been elated when you found it.
It was one of a couple of objects put on at that time, and I chose that one to try and go for it. Just had enough time to do so. It wasn't where it was supposed to be, so I had to chase it a bit, and it was great. By the time I found it, it was just in the nick of time. Clouds were rolling in, the dawn was coming up. So
yes, I know that feeling. I know that very well. So you found the object. What did you do then?
Well, as I normally would, I'd just have a look to see where it's going in the next few days. So I used the discovery positions that were obtained in America together with mine,
right?
And it worked out the orbit, which showed that it was going to make a really close pass to the Earth in about 5 days from then.
Did you feel, oh my word, this
well,
is the end?
Not quite, but it was exceptionally close. So,
it was, yeah.
And right from that very beginning, from that recovery of it, it was obvious that it was going to be very close. So it was always exciting when that happens.
There are around 8,000 near-Earth asteroids out there. Too many for professional astronomers to track. Amateurs like Peter play a valuable role pinning down these astronomical vermin that could prove vital if one were heading for us. In actual fact, what size objects really pose a danger to the Earth?
Well, a big problem would be a kilometre diameter size object. That would cause quite a catastrophe on Earth.
Right.
There are a number of those that have been discovered, near Earth objects, but all of those have been observed enough to know that they're not going to hit us in the foreseeable future.
But there is a great potential for material out there.
Well, there are a lot of small ones, and small ones 100, 200 metres across can still cause regional problems.
Right. Our last regional problem happened in 1908 when an asteroid hit Siberia. It flattened 100 million trees over an area of 2,000 square kilometres. That's the equivalent of everything inside the M25. And I have to ask, if you should discover a tremendously large asteroid heading our way, what would you do? I'd go down to the pub.
Okay,
that would be
I'll try and get another few positions on it.
Dedicated to the last. Peter, thank you very much.
Okay.
Some time ago, somebody came to me and said, what would you advise me to do if we saw a mile-wide asteroid heading straight for the Earth on a certain collision course? I said, I'd recommend this. Repeat very slowly after me, Our Father. And that's as far as I got. At least there's plenty to see in the sky, and Pete and Paul are outside waiting for us.
Well, Pete, only a few hours of darkness this time of year, but nevertheless, plenty of things to look at.
There are. In August, you really have to cram your observations in, don't you?
Cram them in, yeah. So, what do you think we should look at first?
Well, we've just been talking about the Dawn mission to go and see Vesta and Ceres, so why don't we try and locate where Vesta and Ceres are in the night sky? Amateurs can see them with just a pair of binoculars or even a telescope.
Indeed. Well, here we are, Pete, with Patrick's 12.5-inch reflector. One of my favourite telescopes here, actually. It's the one I normally use. But you don't need a telescope as vast as this one to see Vesta, do you?
You don't at all. I mean, Vesta is actually the brightest of the asteroids, and you can see it in a pair of binoculars fairly easily. And at the moment, Vesta is actually coming to opposition. It comes to opposition on the 5th of August.
So it's opposite the sun in the sky.
That's exactly right. And that's the time when it's at its brightest. Right. And this is a particularly good opposition of Vesta because it will be just bright enough to be able to be seen with the naked eye.
If you're in a dark sky.
Well, it's slightly brighter than the planet Uranus, not by very much, but it is slightly brighter than that. So that
telescope will show its disc, won't it?
If you've got a big telescope, it has got a tiny disc, but really binoculars are the way to secure the deal and just get a glimpse of it. And at the moment, it's in the constellation of Capricornus, the sea goat.
The sea goat, but that's not what you've called it.
It's a bit like a misshapen triangle, but to me, it always looks a bit like a misshapen sandwich.
Right.
And it ends the month very close to the star Psi Capricorni.
Oh, very nice. So some easy pointers to find it then. Vesta, of course, not the only asteroid we have in the night sky. We also have Ceres, named after the goddess of cereals.
Is that so?
It is, yes.
Well, Ceres was the largest of the asteroids. It's been reclassified now as a dwarf planet.
What would it be next week?
Well, it's actually quite a lot fainter than Vesta, and you will need a pair of binoculars, or a small telescope with wide field eyepiece will pick it up as well. But it's in a rather obscure part of the sky.
It's in Cetus, isn't it?
It is. It's quite close to the tail of the whale. The tail of the whale is marked by the star Difta,
Yes.
or Deneb Katos. Depends how you
I
want to call it.
Difta.
Difta means frog, actually.
Does it?
Yeah, Deneb Katos means whale's tail, so perhaps Deneb Katos is a more appropriate
Okay,
name.
and this is where we can find this asteroid.
Yeah, it's moving in quite a small arc around that region, so again, you will need to use optical assistance to find it, because it's fainter than naked eye threshold.
Well, we don't just have dwarf planets and asteroids, we also have the other planets, and Mars is making a comeback.
It's been gone for ages. I really miss Mars, actually.
It has. It's returning into the morning sky now, and so there's a couple of nice events to look out for, isn't there?
What's happening is Mars is moving to the south of a rather lovely open cluster known as Messier 35 in Gemini. Now, have you ever seen Messier 35?
Possibly by accident.
It's a really nice open cluster. In fact, it's a very strange open cluster because there is a pattern of stars in there that draws the outline of the space shuttle coming into land.
Really?
Trust me, it does.
You didn't just make that up.
I didn't just make that up. But if you have a pair of binoculars and you look at M35, or you look at Mars rather, which would be the brighter object, and then M35 will be above it on the morning of the 7th of August. So that's well worth going to look at.
However, moving on from a planet with not much detail on because it's small to the enormous planet Jupiter. This is making an enormous comeback.
To be honest, Paul, over the next few months there's going to be one word, I think, which is going to sum up Jupiter, and that will be wow. It's going to be an incredible sight for us.
It has, and we have some interesting satellite phenomena. So its largest satellite, Ganymede, and as you say, it's the
largest satellite in the entire solar system, bigger than Mercury.
It is, and if you go out in the mornings of the 7th, 14th and 21st of August, you'll see Ganymede passing in front of the Jovian disk, which we call a transit, and Ganymede and its shadow passing in front of the disk is quite a spectacle.
It is. That shadow when it's on the disk is incredible because it's so round and dark.
It is very black.
Yeah.
It's so hard to miss it. And I've seen it in a 4-inch telescope watching it go through. Beautiful thing. And I'm very, very excited to have Jupiter back because it's been in the murk for all these years and now it's coming back. Well, good for us. It's climbing higher in the sky.
It'll be about 50 degrees up at its best, and that's incredible. The view we're going to get of it is going to be amazing.
Well, Pete, all these wonderful things to squeeze into the few small hours of darkness in August, so I think it'd be quite interesting to go out and look at some of those things.
Pete and Paul, thank you very much. Back in my study, there's Chris North and Chris Lintoff. I'll begin, if I may. A new satellite of Pluto has just been discovered. We know 3, the big one, Charon, and 2 small ones, Nix and Hydra. Now, this new satellite is again small, 20 kilometers across, but there it is, and of course, a name has got to be found for it. Simply something to do with the underworld. Well, my suggestion is Thanatos, after the god of death, but I wonder what viewers think, so we invite viewers to send in their ideas about naming the move of Pluto. So there we have the outer solar system. But what about the inner planets? Mars back in the news?
Yes, we talked last month about the sad death of Spirit, which has now been abandoned on the surface, but its twin Opportunity roves on. It's just past the 20-mile mark, would you believe, for a mission that we say all the time was supposed to last 90 days, and it's now gone more than 20 miles, and it's approaching Endeavour Crater, which is this deep crater that we've been waiting a long while to get a look at. So I think Opportunity is about to get very exciting. And of course we also have Curiosity, which is the next probe to Mars, sort of the size of a big car, which is going to do fabulous things, and that's been shipped from JPL in California, where it's assembled, over to Florida, ready for launch later this year. So
What about the landing site on Mars?
the choice is a wonderful crater called Gale or Gale. I'm not sure which it is. Gale crater. Well, I was close. So Gale crater, and the thing about Gale crater is it's much deeper than anywhere we visited on Mars before, and that means you can get much further back into the history of the Martian past. So fingers crossed for a safe and rather rocky landing, and then we'll get to see a lot more of this part of Mars.
Where next then?
Well, we want to head a lot further out, and we want to go out to the Large and Small Magellanic Clouds. So these are, the Large Magellanic Cloud is 160,000 light years away. It's a small galaxy that orbits our own Milky Way galaxy. And Large and Small Magellanic Clouds appear to have a very mixed past. It's something we don't understand. This is stars seem to have been shared between them somehow. So this is a study of the stars in the Large Magellanic Cloud.
Yeah, and this is a new result. It turns out that about 5%, so 1 in 20 of the stars in the Large Magellanic Cloud don't look like Large Magellanic Cloud stars, but look like their cousins in the Small Magellanic Cloud. So the stars must have been swapped, and that must have happened relatively recently. So these two galaxies, as they orbit the Milky Way, must have been interacting with each other, grabbing each other's stars, exposing each other to their gravitational force. And I think it's telling us that the area around our own galaxy is quite a complicated place. We don't quite understand the history of anything we see around us, so that's rather fun.
What else do you have for us?
Well, we've gone from the Large Magellanic Cloud to something very close to home, which is right behind me here. This is a new award from the Royal Astronomical Society. I think you've seen already. This is the Patrick Moore Medal, which is not for you. It's for the teacher or educator who's done something remarkable to inspire interest in astronomy. And so the Royal Astronomical Society have asked us to tell people to send in their nominations for this award.
My name is after me. Many people have done so much more than I have.
Well, you inspired both Chris and I, right, Chris?
Yes, it's very easy to nominate people. You can go onto the RAS's website. So you go to www.ras.org.uk/Patrick Moore Medal, and you can nominate the person or the teacher who inspired you most in astronomy or geophysics. Well, there's one last news note, and that's some worrying news from the United States, which is that the Congress, their government, are considering cancelling the James Webb Space Telescope.
Oh, I heard about that. I can hardly believe it.
Yes, it would be a disaster for the future of astronomy in many respects. Well, a short while ago, I went to the Rutherford Appleton Labs to take a look at one of the instruments that's being built in the UK to go on the James Webb Space Telescope. The Rutherford Appleton Lab in Oxfordshire is where they design and build telescope instruments. The latest is the mid-infrared instrument, or MIRI, and it will soon be fitted onto the world's most ambitious satellite, the James Webb Space Telescope, or JWST. Before it can begin its long journey, it has to be tested to withstand the conditions it will encounter in outer space. To get close to MIRI, I have to put on this attractive bunny suit. I don't think I've ever been so clean. This is the test chamber, and inside, MIRI is being subjected to the harsh conditions of space. What we have here is its twin sister. Light comes in from the massive telescope to this part down the bottom. It's fed up to the camera, where the images are taken, and a small amount is sent up to the spectrometer, where the light is spread out into its range of wavelengths, so we can pick out specific types of element and molecule, and work out what their chemistry is like in outer space. The JWST has a mirror 6.5 meters in diameter and will look at longer wavelengths than Hubble. This allows it to see cooler objects, providing astronomers with views of the formation of galaxies, stars, and even planets. Professor Gillian Wright has been involved with designing MIRI and the JWST since the 1990s. It's taken a life's work to help construct the replacement for Hubble.
It differs from Hubble in that it's a much bigger telescope, and we know from, for example, the discoveries that have been made in the Hubble Deep Field that galaxy evolution happened much earlier in the evolution of the universe than we knew before Hubble. And so what we would like to do is to study those more distant galaxies, and to do that we need a much bigger telescope. So that's where JWST will really follow from the science that's been done by Hubble. with new science in complementary ways. It's one of the reasons that we built MIRI, was to try and learn more about how planets form around stars, and also about how stars form, because we know that stars form in very dusty regions, and so somehow the chemistry of the dust is all tied up in this process in making it work.
Taking images in the infrared is technically challenging. With 1 million pixels, MIRI's mid-infrared camera is the largest ever built. Infrared astronomy has come a long way in just a few decades.
In fact, when I started as a mid-infrared astronomer, we had 1 pixel, and that was the best detector you could get. Detector technology has changed a lot. We know how to do big telescopes in space now with Herschel and then JWST, and so people talk about this now as becoming the era of the infrared, because a lot of the cutting-edge discoveries we expect to come from this, working at these longer wavelengths.
Getting MIRI ready for its voyage means testing everything will work in the cold, hard vacuum of space. So here we are in the MIRI test control room, and we've got on the screen real data from the MIRI instrument in its test chamber. What are we seeing here?
Yes, so this is the data from the MIRI imager channel looking out at the test chamber, and it's looking at a tiny point source here, which we're using to simulate a star.
Right.
And then, because we're looking in thermal infrared wavelengths, you can also see on the image all the structure that supports that simulated star.
So it's looking at something that's the same temperature as a cool brown dwarf, something like that?
Something about 800 Kelvin, yes.
Right,
or a very cold star, maybe.
The JWST is pioneering technology and is technically ambitious. Its final destination is 1 million miles from Earth, so unlike Hubble, astronauts won't be able to repair it if something goes wrong.
No one's ever done a telescope with optics this accurate and put it in space before, and it's not really so many years from we learned how to do telescopes this size on the ground, and now we're already trying to put one in space. And it's also ambitious because it's cooled by a sunshade, and no one's ever really done a mission that's so totally reliant on the sunshade for its cooling. So it would be the first time that's done as well. And it's deployed because it's too big to fit in a rocket. So we have to unfold the telescope in space.
In the next few weeks, MIRI will have completed its tests and be shipped to NASA to be fitted onto the spacecraft. However, with budget problems in the US, there is a real threat that the JWST could be scrapped. If this happens, the loss to us all would be profound. The chance to understand our universe closed for decades.
So let's only hope that common sense prevails. Meanwhile, we had some lovely pictures sent in, and some here of noctilucent clouds, and these are really beautiful.
They're incredible. One of the best things about observing in the summertime, I think. If people want to send in their own images for us to look at or to use on the programme, they can do so through the Flickr section of our website at bbc.co.uk/skyatnight. We have some wonderful images there, but the image I'll be staring at this month is this one from the Herschel Space Telescope. It's an infrared image of our own galactic centre. And if you look carefully, you can see this twisted loop of material around the centre itself. And it's really quite difficult to explain why that material's there or why it's in this twisted form. So I shall be staring at that and wondering for most of the next month.
I'm quite sure you will.
And the image I've picked out is one from orbit around Earth. So this is an image by an astronaut on the International Space Station. And what's stunning about this is quite how much is in there. You've got the solar panels of the space station. You've got one of a part of the space shuttle Atlantis. You've then got the Earth and the aurora in the atmosphere, and then you've got some of the star clusters and stars towards the centre of our galaxy. And of course, this is one of the last times we'll get an image with the space shuttle in orbit.
Well, thank you both very much. When I come back next month, we'll be talking about the future of space exploration. We'll be joined by astronaut Piers Sellers. So until then, good night.
Next this evening, stay with us as Horizon explores how science has influenced our parenting styles over the last 50 years in Carrot or Stick, a Horizon guide to raising kids. Next.